Thanks. Great. All right. Thanks very much. Can everyone hear? The sound is working. It's all good. All right. Excellent. And I think I escape out of this and I open my slides. Okay. Yeah. All right. I'm too used to teaching in lecture halls like this with the mask on, so it comes naturally at this point. All right. So open that. All right. Yep. We're gonna open with preview. All right. Okay. Well, yeah, thanks very much for the invitation to take part in this event. It was really a pleasure to be able to come here and express my own appreciation for the incredible leadership role that the Simons Institute has played in the theoretical computer science community and the computing community more broadly over these past 10 years. And this is, it was a chance to kind of reflect on these past 10 years overall, my own connection to Simons Institute and also Berkeley more generally. And really to reflect on how 10 years really is a long time in a field, especially a field that's changing as actively as computing, right? 10 years is a long time from the perspective of entire new communities that form, changes in one's own research, and even, which will sort of be some of the theme of my talk, changes in the way, that I think back on topics that I like very much and think about them in new ways, right? So changes in the field, it obviously goes without saying that there's been this enormous explosion of interest in what you might call the societal implications of computing, right? The past 10 years has seen computing, which had already become this unbelievably powerful force in the online world, really sort of step out from the online world into areas like employment, education, the legal system, the political process. And as we think about that, we think about the impact that the design choices that we make in purely technical systems have on those societal institutions. And active research areas have grown up. We see, conferences that, really had, a lot of impact from, a lot of sort of inspiring generative, sort of roles played by people with, either in the theory community, with training in the theory community. Many of these have both a Berkeley and a Cornell connection, as many of you know. And all of this really is just really powerful set of new areas that have emerged, thinking about these societal implications. And my own work has certainly been informed by these kinds of themes over these past 10 years. And I mean, one of the other, of course, amazing things that, those of you in, all of us in academia appreciate is the way in which 10 years is long enough that, people that you did not know 10 years ago become very close colleagues of yours. And so, as we've thought about these issues, right, the way in which computing plays a role, both in, its societal impact and also in the potential for change. For example, in this paper at FACT from a couple of years ago with a number of colleagues, some of whom are now your colleagues here at Berkeley as well, we've been thinking about sort of the different roles computing plays here, right? And a lot of these are really recognizable for, when we think about, the role that theory plays as a unifying force in these kinds of areas, right? Computing as a diagnostic, as a formalizer of what's happening in society, as a rebuttal to potentially superficially conceived solutions that on deeper inspection might not actually work. Computing as synecdoche, right? A word from literary analysis in which the part stands in for the whole. And this is sort of, I think, an important, thing that has been coming up increasingly, right? Synecdoche, when we say the White House, but we mean the executive branch of the US government. We say the market, but we mean, not the marketplace, but the entire economy. Similarly, computing in many of the debates that we see playing out is often a stand-in, right? That social media becomes a stand-in for the entire media and public information ecosystem, where new developments in computer security become really synecdoche for broader conceptions in security more broadly. And maybe this is part of how theory plays some of its really pivotal role here, which is that it allows us to generalize ideas from computing to these issues much more broadly, right? To really take in that picture much more broadly. And that's really part of the power of theoretical approaches to be able to do that. And finally, not just these new directions, but thinking about the societal impacts of computing really also has caused me to go back and think about topics that I hold very dear to my heart, things like social media, right? Social media. And so when I first spoke here at the Simons Institute shortly after, at the kickoff conference, shortly after it was founded, I put up pictures like this, which were quite recent at the time, arguing that something dramatic had been changing in the world, that people were moving online, that we were seeing implications for your everyday life, as in this person's Facebook network neighborhood, for political mobilization, as in the spread of this chain letter across the internet. And of course, the past decade, social media has been, a crucial issue for everyday life, for civic discourse in the political process, and it surely will be in the coming decade as well. Now, what's interesting, of course, is that social media, in a way, media has always been social, right? There's something funny about calling internet platforms social media, because if you go back to some of the founding texts of the theory of mass communication, things by people like Elihu Katz and Paul Lazarsfeld, they were talking about this as well in the 1950s, right? So in 2004 at a workshop, I had the good fortune to meet the first author of this 1955 work, Elihu Katz, and had a fascinating conversation about how both he and I, 50 years separated, were interested in the disruptive effects of technological change on the political process, right? For him, it was things that we now think of as sort of quaint, like the radio and TV, and for me, it was blogging and social media. But they were arguing even then that in the end, these technologies were not really what was affecting people's opinions, in this case for voting, right? Rather, when they asked people what had contributed their opinion, it was other people. So if media was always social, yet this feels new, what's new? And the real point is that modern social media is algorithmic media, right? That now what you're seeing is computationally mediated. It's finely targeted, often to you specifically, and it's being optimized, right? By, the very kinds of algorithms that we all talk about every day. And those are some of the crucial feedback loops to model. Now, because media is social and because algorithms can optimize this, we ultimately can manage actually quite a bit of complexity in what we find in the online world, right? So I try to sort of keep track of when I notice things on this, and particularly sort of notice the way sort of my own reading, or I'm sure all of your own reading, can sort of effortlessly map out things that are really quite complicated, right? So, for example, halfway between back then when I gave those talks and now, spring of 2016, the Democratic presidential primary, Hillary Clinton, Bernie Sanders, Rolling Stone decided to endorse Hillary Clinton for the Democratic nomination in 2016. And this blog that I've never seen before or since, that's apparently called thepeoplesview.net, decided to talk about a brilliant response from a millennial to Matt Taibbi's displeasure over this endorsement that Rolling Stone had of Hillary Clinton. And I screenshotted this at the time as I was thinking about social media, because there's something unbelievably complicated about this sentence, right? Your brain processes it. It doesn't at first seem like a particularly strange sentence, but it's not a sentence about Hillary Clinton, nor is it even a sentence about Rolling Stone's endorsement of Hillary Clinton. Or rather, Matt Taibbi, a former, a sometime writer for Rolling Stone, was apparently displeased of this, but it's not about his reaction either. It's really about the millennial who had the brilliant response to it. But you're not hearing from the millennial. You're really hearing from thepeoplesview.net. So there's a cast of at least 5 characters in this story, right? The media is social, right? The story is about the connectivity and what everybody thought of what everybody else was saying. I should just, of course, add that you're not actually reading thepeoplesview.net. You're listening to me give a talk about this. So we can add even some more characters to this story. So, right, so media has always been social, but algorithms heighten the complexity of it, right? It allows us to assemble these kind of complex structures. And it's being assembled by platform algorithms that are effectively trying to give us what we want. So now let's get to the next part of the question, which is, why don't we usually feel like we're getting what we want, right? If you were to go online and read the news media, read what your friends have to say about social media, the overriding sentiment would not be one of customer satisfaction, right? It would not be a sense that this is really the experience I wanted to have. Why is that, right? And is there something that we can say about that? And I think that's been certainly one of the sort of changes in my own way I've been trying to approach these questions, that 10 years ago, the frame for example, the talk I gave at the opening conferences was one of optimism, right? I think I'm, potentially optimistic by nature, perhaps. And the idea that we were connecting people feels like, this is a good thing. And the idea that algorithms are going to help us find what we want, we hope this is going to be a good thing, right? Why do we feel that this is not exactly entirely what's happening? So one issue is about conflict, right? One point is that the technologies as they've been set up have been sort of leading to a lot of conflict that arises out of that connectivity. This is actually not going to be the part that I'm going to focus on, but I'll mention that there's been a lot of interesting work, a lot of which raises interesting mathematical problems in the network dynamics of this and the probabilistic dynamics of how things like political polarization arise, how misinformation spreads, how we can detect it, in beyond polarization, radicalization pathways whereby increased media consumption, some have argued and others have debated empirically, might lead people to more extreme opinions than they had initially. The idea that there actually media should be yet another domain where we actually take seriously the idea of the adversary, right? A favorite topic in theoretical computer science, right? That, right, social media, which is algorithmic media, also can become adversarial media, in which adversaries may attempt to actually sow discord among the participants purely for the sake of discord. And there's some work that Jason Gaetandi, Eva Tarish, and I have been thinking about recently on those kinds of questions. The part I wanted to talk about mainly, though, here is some new work that Senthil Mullainathan, who'll be a speaker here on Friday, and Manish Raghavan, a Berkeley alum and my former PhD student, will be starting at MIT this fall. The three of us have been thinking about a different kind of conflict. One that's also recognizable, but has not somehow shown up nearly as much in the kinds of models that have been built to date. And that's not about the conflict between distinct people, but about the conflict social media creates within each of us, right? The conflict that's happening within yourself as you consume social media. And the more we looked at all of these issues, we began to feel like these issues we can't fully understand without understanding the internal issues, the internal conflicts that come about. Now, it's natural to ask, like, so what do we mean internal conflict? What is this internal conflict? So let me show you some more recent headlines, right? So the fact that we have to invent a term called doom scrolling, right? The fact that you have a hard time stopping yourself late at night from scrolling through public health experts on Twitter telling us that certain, case counts are going, quote, nearly vertical and that we're all in big trouble. And yet, this simply heightens your stress, suggests that there's part of you that wants to stop reading and part of you that keeps reading, right? The fact that people post on Reddit questions like, how do I spend less time on YouTube? In some sense, the answer feels obvious. Perhaps you should stop going to youtube.com, right? And the fact that there's apparently a profession called professional internet quitter means that people feel like they need help in this domain, right? There's, again, this complicated, right? There's two parts of you here, right? There's Facebook. There's some party that wants to use Facebook and some party that wants to override the party that wants to use Facebook. And apparently, when you seek help on this, that person you're seeking help from is effectively helping one side of you in their struggle against the other side of you. And so Senthil and Manish and I started from here, and actually from some extremely useful conversations which we had with teams at some of these large internet platforms who very much, obviously, to say the least, are aware and wrestling with these issues. And to think about, could we, again, one of the things we might hope to do is provide some kind of a sort of theoretical vocabulary for thinking about what's going on. So if we want to provide some kind of a theoretical vocabulary, it helps to start with some kind of a well-grounded behavioral theory of what's happening, right? This is not new. And one advantage of working with Senthil on these projects is Senthil brings several decades of experience working on exactly the kinds of behavioral biases and behavioral conflicts in other domains that we sort of see playing out in this media environment. So let's go back to the behavioral science and the behavioral economics of self-control, right? The question of why are we not able to exert self-control when we go online? And in the language of behavioral science, a lot of this is about the distinction between want and should, right? There's some activities that are want activities and some activities that are should activities, right? And a simple picture tends to sort of drive this home. There are things we want, and actually the sort of assortment of food outside is a kind of real life worked example of this. You can go check it out later, right? So, and the food literature is actually a lot of where, some of this really thing comes from. But it's also true in media, right? People studying media consumption have also thought about the distinction between want and should, right? Your flight is landing in 3 hours. You're looking for movies on the airline's entertainment system. You could watch the fascinating documentary about a font, Helvetica, or you could watch an Avengers movie. I actually recommend the font movie. It was quite good. The font movie, as you can see, actually says at the bottom, I don't know if you can see this on screen, start watching with your public library card or university login, because they're pretty sure that the only people watching this either have a public library card or university login. And it's the same potato chips versus salad, right? Part of you wants one, part of you wants the other. Now, the concern here, I should say, before we get to the concern, these are not just anecdotal examples, right? It's in the nature of behavioral science to take anecdotal examples from everyday life and do empirical studies. And so actually this team of behavioral scientists who were students and postdocs and faculty at Harvard at the time looked at both the food domain and the media domain, Milkman, Rogers, and Bazerman, and found these distinctions actually show up in, sort of just found data, right? So you look at online grocery orders, and orders placed further in the future tend to contain more should items, right? More vegetables, more healthy food, nearer, more want items. And similarly, when Netflix moved from being, right, those of you old enough to remember, Netflix was a mail order DVD company. You put in your request and DVDs would arrive in the mail. And so the world actually experienced a massive behavioral science experiment when they switched to streaming, because Netflix had always been about what do I think myself 3 days from now will want to see, possibly a movie about the font Helvetica, versus what do I want to see like literally right now at the press of a button. And when that change happened, you could actually see the shift in what movies were actually selected. And of course, there was some interesting timing there, because for those of you who, again, roughly 10 years ago, remember the Netflix prize competition. Netflix offers $1 million to anyone who can improve their recommendations. That was on data from the mail order era, but the solution arrived roughly as they were pivoting to the streaming era. And so there was a kind of massive shift in actually what the data was potentially now going to be telling us. Right? Okay, so obviously this is, the self-control issues are in turn grounded on, issues in time and consistency, right? There are multiple time scales happening here. Okay, the reason to be concerned, of course, is that we have these problems when we select, and that shows up in the data on how we select. And platforms are using that data to try to figure out what we want. Right? That's the crux of it. A basic question, maybe the basic question platforms must answer is, what do users want, right? What does this user want? What does any of us want? And it's sort of, in 10 years ago, I actually was sort of, a sort of mantra that I was very happy to say in talks was, the amazing thing about the online world is we have unbelievably fine-grained data, right? We have this click-through data that shows in real time what everybody, quote, wants. And that is fundamental to how these platforms, right? These platforms would not work without that, right? The principle of revealed preference. People choose what they want, so choice reveals preference, right? We can't do away with that. But in a sense, what we're here to argue is that that question is much more complicated than it seems, because the question of what you want is much more complicated than it seems, right? And that really, we should model that selection as happening through a conflict between multiple sets of preferences. Right? The reason this seems so hard is that you do not have one set of preferences. You have multiple sets of preferences, and different of them are in control at different times. And what you're watching in that data, which was so fine-grained and so high resolution, is this strange interleaving of the choices you make as different parts of you are in control. Right? And that, if we sort of just naively take that as the data, we're going to have a very hard time decrypting what's going on where. Right? It's again sort of like, like food. And I think we sort of see the food analogy at this point. You're at a party and you stand next to the bowl of chips and you sort of mindlessly finish it, and the host shows up, and part of you would like them to refill the bowl, and part of you hopes they take the bowl back to the kitchen and don't bring it out again. And the point is that, when you sort of naively think about platform algorithms, and I should stress, the fascinating conversations we've had with people at these platforms, they're certainly anything but naively in their thinking about this. But when you just sort of approach this as a first pass, a simple recommendation algorithm is going to refill the bowl of chips every time. I mean, it knows what you want. It just saw you finish a whole bowl of chips, right? And so that's essentially the problem that you're fighting against, right? That you see people clicking on things, what is the signal that might tell you maybe this is actually where they want to stop, even though they're still clicking? Okay, so that's the issue. Now, the point is that, and let's try to start building a model now, right? Like, it'd be nice to actually have a language for talking about this. I've given you some behavioral science concepts and some empirical studies, but let's actually try to build a model of this conflict in the specific context of social media. So, and the point that we'll see is that whether revealed preference leads to the correct conclusion, it's not that revealed preference is right, and it's not that it's wrong. It's that whether it leads to the correct conclusion depends on the nature of the content. Okay, and whether the content is sort of salad-like or chips-like. And so that's what we would really like to talk about. When does revealed preference work? When does it not? How do we recognize the distinction between these two things? And to appreciate that at some point, quantity becomes quality. The problem becomes qualitatively differently when you imagine that the social media platform is really like the billion-product grocery store, where every time you touch the shelf, it's reconfiguring. And meanwhile, in the back, the food is being bioengineered to optimize for your particular taste, right? So the speed at which things are changing is just very different from the domains in which behavioral sciences approach this, right? It's very different from the speed at which news editors decide what tomorrow's front page will say, or grocery stores decide what to stock. This is happening literally as you're scrolling through your timeline. Lower down the timeline is actually reconfiguring based on what you're pausing to look at, okay? That's what we have to deal with. Okay, so for a model, start with a simple model. And for the sake of being able to sort of digest all this in real time, I'll sort of keep all the kind of knobs and dials turned down to sort of as simple as possible. In the work we've been doing, we're looking at a number of other generalizations. But let's actually just start with a linear content feed, right? So you're scrolling through a news feed, a timeline, you're auto-playing videos one after another. And so, just items t equals 0, 1, 2, so forth. Your main decision is, do you continue or do you stop? Okay. And then later on, we can try to add, branching, which choice do you pick, and so forth, because a lot of the ideas are going to just carry over to that. And again, you have conflict between your preferences. And so to, again, borrow some language from behavioral science, let's say these are these two sets of preferences, system 1 and system 2. Now, system 1 and system 2 actually get used in a lot of parts of behavioral science. And we're going to sort of only use sort of pieces of it. But system 1 is the impulsive preference system. It acts faster. Right, so it moves first. If it's engaged, it just acts before planning. System 2 is the slower, retrospective, more planning aspect of the preferences. And it's going to actually make a plan. Do I want to be here? Am I still getting value out of this? It's able to plan, do I want to go on this platform at all? Okay, and system 1 just impulsively grabs the next chip. Okay, so how should we model system 1? Now, system 1 has preferences. It just acts on them very quickly. So item T, let's imagine, produces some utility U sub T for system 1 drawn from some distribution U. And system 1 is not really adding up utility over time. It's just saying, is this in my interest or not? So the key parameter here is simply P, the probability that UT is positive. Okay, UT greater than 0 is probably P. And if so, system 1 continues on to item T plus 1. If UT is less than or equal to 0, system 1 is not interested in what it's doing right now. It temporarily powers down and hands over control to the slower moving system 2, which wakes up and gets to actually decide whether it wants to be here or whether it would like to leave, right? These are these sort of moments when you're able to reflect and say, maybe I should actually stop eating chips or stop scrolling through public health experts telling us all how doomed we are. Okay, so what does system 2 do? So system 2 uses long-range planning, but only when it's in control. So it too has preferences. And you can start imagining, right? So it has preference VT for item T from some distribution V. You can start imagining that presumably the correlation between this distribution U and distribution V is going to be important, right? Okay, so let's say the average utility that system 2 gets is V bar from, because it doesn't know what's coming, but in expectation, you sort of know the quality of tweets you're going to see. You sort of know the quality of videos you're going to see. But it also has an outside option, right? It has some reason it wants to leave. This outside option W for leaving the site. So its net utility from item T is VT minus W. It doesn't know the exact utility of future items, but knows that for the next item, its expected utility is V bar minus W. Okay, we need one more thing, which is if V bar is bigger than W, why does system 2 ever want to leave? I mean, every time it's in control, it sees that the expected future utility is positive. And the reason is satiation, right? Right, so this is a hedonic activity, consuming media, eating dessert, snacks, whatever. And so we're eventually going to reach diminishing returns from this hedonic activity. And so we're going to imagine that system 2 is receiving these diminishing returns. There are various ways to do this. And again, for this talk, to keep everything sort of that we can all sort of do the math in our heads as we're watching, I'm going to take the simplest formulation that we use. We imagine that system 2 goes through a kind of on-off satiation transition. So at every step, with probability Q, it decides it is now satisfied and it is done. It would now prefer to leave. Okay. So, and it can plan for this. It knows that T steps from now, the chance that it is going to actually want to see this item T steps from now is Q to the T, right? It has to survive T coin flips going to the future. Okay, and that's how system 2 thinks about things. So the content has 3 parameters that matter. There's the value of the content per item, right? And that's this V bar minus W, value minus outside option. There is the satiation parameter, right? The rate at which you sort of saturate on the content, which we'll call, the span. That controls the expected time span that system 2 wants to be there. That's probably Q that system 2 remains interested. And then again, I'll take this term from behavioral science, moorishness, right? Certain activities are moorish in that system 1 just keeps wanting more of them. And that's the probability P that system 1 is in control when consuming a piece of content. Okay, so that's how this works. A given piece of content, if system 1 is engaged, it gets to control, it's in control and it moves on. If it's not engaged, system 2 wakes up and can actually do some calculation and decide, is my future expected value taking into account the value of the outside option and the upcoming satiation and the chance that I'm not going to be in control for a while? All of that, does that justify staying on the platform? So actually, with that in mind, we can actually just work out what should system 2's calculation be, right? It is all of those things. So system 2 can think, okay, here's what my session on the platform is going to look like. Well, it's going to go in 2 phases. First, before I satiate, and second, after I satiate. In phase 1, system 2 wants to continue while it's waking up. And again, because we're choosing the simple model that we can work out, just here on the slides, this is a memoryless process. And so every time it wakes up, it's doing the same calculation. From any point where it wakes up, the expected number of steps left while it still wants to be there is 1 over 1 minus Q, right? And if we had something that wasn't memoryless, we'd have to do a more elaborate calculation for system 2. And the expected utility for this part is this, utility per time divide, times 1 over 1 minus Q. Okay, that's the part it gets. Then it satiates. Does it get to leave? Well, not immediately, because system 1 might be in control, right? There's now this sort of coda, this epilogue to the whole thing, where system 1 is in control and it's impulsively continuing, even though system 2 is no longer deriving value, right? And in that sense, it's actually gaining utility of minus W every step because there's this opportunity cost from being trapped on the platform here, right? And how long is this going to go on? Well, it could last 0 steps. So there's a factor of P, but it's P over 1 minus P, right? The 1 over minus P times chance P that ends immediately. Okay, so you could think of, right, system 1 and system 2 go to a party together and system 2 is enjoying it for a while, but at some point system 2 wants to leave. But do they get to leave? No, because they have to extract system 1 from the party. And system 1 is impulsively having a whole bunch more conversations while system 2 would really rather leave, right? And that is the experience of you, a single person on social media, as these 2 sets of preferences are fighting for control. Okay, so system 2's utility is this random variable, right? This random variable S, which is either this thing, right? The value from phase 1. I guess I can, if I point with this thing, you can see it, right? Yeah, there you go. Minus the value it loses in phase 2. The max of that in 0, because the point is system 2 in our model, and again, actually, this is a fascinating point to consider. Who controls the decision to go to the platform, right? And I'll actually come back to this point because there are design choices that actually affect this. But let's imagine, the platform requires you actually getting your phone, opening it, whatever. So that's a planning activity. That's not an impulsive activity. System 2, let's imagine this model is in control, but let's go back and revisit that later. So it only does that if expectation of S is non-negative, okay? When the user chooses to visit the platform, there's a second metric that's very interesting, which is the length of the session. The length of the session is just the length of the first phase, 1 over 1 minus Q, plus P over 1 minus P, the length of the second phase, okay? Now, the length of the session is not just sort of an incidental quantity here. It is a quantity that is sort of heavily thought about in platform context, right? It is the user's level of engagement with the platform, right? If you're looking at metrics for the platform, you might discover that last month, people spent 22 minutes per session on watching videos on the platform. And this month, they spend 24 minutes, right? Engagement has gone up. Okay, and that's this expectation of t. And then there's this invisible thing, utility, right? Where the user is happy because they spent 24 minutes instead of 22 minutes. That's sort of the mystery. And that's right. And that lets us sort of write down this tension, right? That we have these two quantities. And if we think about session length t as measuring engagement, what is the relation to utility, expectation of s? And even a model this simple sort of shows us how these things are partly aligned and partly misaligned, right? They each have a first term that has 1 over 1 minus q, a factor of 1 over 1 minus q, right? So increasing the span of the content lengthens sessions and makes people happier, right? And that's in a sense somehow the basic argument for engagement optimization, right? It's from the idea that if I can have things where the diminishing returns operate slower, then people are just getting more value out of it. But the second term causes t to go up and s to go down, right? And so the problem is if I'm just, I can't know what's in your mind. We'll come back to that point too, right? Maybe I can ask you survey questions. I can sort of ask you how satisfied are you today on the platform. But if I'm just looking at click data, then if I see long engagement, it could come because of the first term, that's a good thing, or it could come from the second term, and that's a bad thing. And more than that, if p gets too high, the user might just one day stop showing up at all, right? Because they're no longer getting value from the platform. So now we've sort of crossed over into this last thing I wanted to discuss in the talk briefly, that now I'm talking about platform optimization, right? Until this moment, I was talking about the user's experience on the platform, a model of your internal conflict. But as we think about it, the platform is choosing, right? It's tailoring the content to you, and it has to decide where in the space do I want to be. And the space we've defined has these 3 dimensions: P, the Moorishness, the appeal system 1; Q, the span, the amount of time system 2 wants to be there; and V, the V bar, the value, right, per unit item. And so the content lives in some feasible region in this space, and implicitly the platform is moving around in the space, right, parameterized by some coordinates it has control over, proposing distributions of content to you and then seeing what happens. And let's imagine the platform can measure engagement, but can't directly measure utility. And so the question is, if the platform is optimized, moving around on this feasible region, optimizing for engagement, what is the effect on utility? And the point is that it's not just the answer is good news or the answer is bad news. It depends on the shape of this feasible region. So let me just show you some examples of some feasible regions to just show you. And so this will mainly be worked examples. I'll mention one result at the end, then I'll wrap up. Sounds great. So first example, imagine there's some base point, on this manifold of possible content, P, Q naught, V naught, and I have control of some parameter X, right? I have this lever. If I'm the platform, I can move the lever. I'm not quite sure what this lever does, but I'm going to try moving it and see what the reaction from the users is. But imagine what the lever actually does is it increases Q and increases V. Well, then obviously the engagement goes up and the utility goes up. And this manifold is sort of the canonical thought experiment why engagement optimization is good. But of course, I might have, when I grab the lever and move it, a different thing might be happening, right? It might be that what the lever is doing is increasing P. Now something different will happen. I will see users spending longer and longer on the platform, right? So as I move this X value, changing P, then we have this plot on the right. The orange curve is time on platform. It just goes up, 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 up. But unbeknownst to me, the utility is going down, 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 because it's getting longer just because people are sort of finding themselves unable to tear away. And it rises to this peak, after which one day the user stops showing up at all, right? So what I've done is, at the moment when the user seems most engaged in the platform, that's the moment when they suddenly stop showing up, right? Okay, and so that's the situation that you want to avoid. And of course, things are always going to be more complicated, right? Moorishness is never decoupled from overall system 2 satisfaction, right? Things that appeal to system 1 typically also appeal to system 2. And so you can imagine we have even slightly more complicated feasible regions where the lever I've grabbed is raising the Moorishness, but it's also raising the value per item, right? Like when I make the chips slightly a bit more Moorish, they also, system 2 likes them more also. And so there we actually end up with some internal optimum. And so part of this content manifold, engagement is a great signal. As I ride up the engagement surface, I'm actually making the user happier. But I somehow have to know where to stop, because as I keep going, the engagement signal won't tell me to stop. Engagement keeps going up as I burn away all the utility, and one day the user again stops showing up at all. And we can build lots of these things by mixing, right? So by creating sort of mixing weights among the content. And so, again, this sort of, I'm carrying this out at the level of worked examples. One general thing that we can show is, if we wanted to characterize when is a feasible region, when for a feasible region is engagement a good signal for utility, or conversely, when is it not, right? So I have some feasible region, I have the expected utility and expected engagement, and then I have the optimizers for both of these, right? A point that optimizes utility, a point that optimizes engagement. And one question is, when does the engagement optimizer produce strictly higher engagement but strictly lower utility than the utility optimizer? And one thing we can show is that they're actually, when that happens, right, when these two signals are actually not aligned, one of two things must hold. One is that I do have greater Moorishness at the engagement optimizer, right? That I've over-optimized for engagement precisely by raising Moorishness. And there's actually a second possibility that comes out of the model and makes sense in retrospect, which is I can also create high engagement with lower value if the span of the content for system 2 is longer, but the value per time is lower. What does that correspond to? That actually corresponds to another thing that platforms know about, which is if the quality of my search results, the quality of my video search results, product search results, Google search results gets worse, you can get this paradoxical effect where users, of course, spend longer on the platform because it takes them longer to find what they need, right? So they're spending longer, they're getting less value, they're still satisfied, they still keep coming back. And you have to recognize that, right? No one wants to spend time searching. And so that's actually the second alternative. And one of these two things, greater Moorishness or essentially lower quality per time, is sort of at the root of this. All right, I will wrap up with just some final reflections, right? Our goal here was to sort of start from the sense that something isn't working with platform optimization based on behavioral data, right? We feel that when we go online, you feel that and I feel that. Behavioral science tells us that there's a reason why we might feel that. And to really try to build that into a model of how to recommend content on online media that really takes into account this internal conflict. And what's been interesting is how this model lets us think about a lot of design choices. I've been talking a lot about how to interpret the data we collect. There are issues like the role of surveys, right? How can I directly elicit information about utility from you by asking you questions, right? It doesn't have to be necessarily invisible. These questions about like the number of options to display, right? I've run through this talk purely about a linear feed. You have to decide when to stop. As I present you with options, right? System 1 now has more things to click on, but there's also greater, you're now maximizing over all those options for value. There's this interesting fact about the benefits of enforced breaks, right? If I mix in, parts where there's like zero value, right? I say time to take a break, and we've seen Instagram introduce this, we've seen TikTok introduce this in the last few months. The model actually tells us that could actually cause users who have gone away to come back, right? Because it's now saying I've actually brought down the Moorishness. Because system 2 can be confident that periodically system 1 is going to power down due to the enforced break, and you can evaluate if you want to leave, right? And it's the fact that platforms are like, we're going to add 30 seconds of boredom every half hour means that this is actually something that can be quite powerful and something that the model is telling us about. Finally, the unexpected benefits of embedding media in other content. I think there's a very interesting question about back to who controls the decision to go on the platform in the first place, right? And obviously, the more friction there is, right, the more you have to like open your laptop, open the browser, right? That's an expensive activity. The more you can just pick up your phone, right, the more system 1 starts to come into play. And it lets you think about embedded media also, right? It's entirely possible to say things like, I normally read the Washington Post, but not on Sunday mornings because they always embed clips from last night's Saturday Night Live. And now suddenly, although I know to stay away from YouTube, I'm suddenly watching YouTube in the middle of this Washington Post article, and system 1 takes over, right? Right, so the whole idea of embedding media in other media means that you may have safeguarded this thing away, right? System 2 is staying away from this thing, but suddenly system 1 is there, right? You see this in the food context, right? You walking through the airport concourse know not to stop and buy the 1,200 calorie cinnamon roll at the kiosk, but the cinnamon roll place in the airport knows to pipe the smell out onto the concourse, which means as you walk by, system 1 is already eating the cinnamon roll, right? You're already engaged. And so this question of like who controls the decision to join is also something that shows up obviously very clearly in this model. So what's been interesting is just to try to create this vocabulary where we can talk about these things that were really sort of hard to talk about, right? Not just, the conflict, not just at this sort of macro scale or the visible scale, but at this invisible scale within each of us. It's been very interesting both sort of, trying to think about the options for models and also talking with, again, teams at a number of these platforms. And I think it'll lead to a lot of very interesting questions going forward. And I think, questions very much in the spirit of bringing together, many of these different areas, many of these different perspectives together with theoretical computer science that I think, the Simons Institute really very much has represented for the past 10 years. Thanks very much.
Thanks, John. That was a great talk. I had a question about the richness of the model. So you might ask about models whether they are rich enough to support various kinds of phase transitions and so on.
Yeah.
So one thing that one might think about here in this context is that there's a phenomenon that might be very important, which is addiction.
Yeah.
And there might be incentives for social media companies to actually engage that side. So do the models that you are looking at actually display all these phases? You might say, well, these are the phases we'd like to see in these models, and do they actually display these phases?
Yeah, so it's a great question, right? So yeah, this question about does it capture addiction? So I think, in some sense, so there is this interesting thing that we're sort of trying to work on. As you think about PQV space, right? And I sort of partition that. I'm able to think about sort of how these. Let me grab those. Yeah, thanks. I'm able to think about sort of how how the platform's decisions relate to the user's utility. And of course, I should emphasize that platforms ultimately are optimizing for long-term value, right? That's even in their self-interest. And so something which is going to sort of turn off users in the short term is not going to be in their interest. But they may not realize that they're steering into that. I think it's part of the challenge. The other issue is so addiction. I think, in the behavioral science literature, addiction has these two components, right? One is the moorishness. You just keep doing it. And that's very much in the model. The second is the attenuation of the stimulus, right? That when you come back, you need more to achieve the same effect. And that actually, right? So that says that some of these parameters would be dynamically changing in you. To achieve, the same enjoyment the next time, you have to spend even longer, right? Because addiction is basically attenuating the signal. That part is not explicitly in the model right now, and that's something we've very much been thinking about trying to include, which would sort of round out the kind of second half of the addiction picture potentially.
Just wondering,
would you say that to a first order approximation, if a platform is ad supported, then it would try to optimize for engagement, and if it is say subscription supported, it would try to optimize for utility?
It's a great question. I mean, so I think if you're subscription supported, certainly the argument is utility. I would say ad supported creates a conflict for the platform, right? So as in there's a discount factor going on, right? Obviously, if you want to maximize your revenue today, I should keep users on the platform clicking on ads. But no platform wants to maximize its revenue today. They want to maximize some infinite discounted revenue over time. And it's very clear that sort of causing users frustration now is actually going to sort of hurt retention in the long run. So you definitely see metrics, I think, that are about playing out over a long time, even for ad-supported platforms. And so now you have these challenges, right? One is the whole set of challenges here, that utility is partly invisible. I can only indirectly estimate it from people returning and so forth. The other is the longer time scale, right? If I show you something and you click or don't, I can get like a huge number of reactions very, very quickly in real time. Knowing whether a change is sort of increasing or decreasing the number of people who sort of come back on a daily or weekly basis is going to be a much slower time scale. And so I think there's also a fascinating set of questions here about the feedback signals, right? So there's sort of a giant reinforcement learning question here going on. The rate at which the feedback is coming in can be at the level of seconds for clicks and at the level of weeks for sort of daily return. Platforms unambiguously would like to be optimizing for return. They want you to still be here in a year. And that's going to be very much against sort of hitting you with annoying ads. But it's very hard to measure and optimize for. Okay.
It always strikes me, we're not all the same. So
Yeah.
it's like, there's some teachers which are better for some students, and there are some different behavior modes. I assume that it's not every person is different, but there's some clusters.
Yeah.
So how's that going through the model?
Yeah, that's it. Right. So the question is like, right, differences in people. So, I mean, so one thing is
Types of people.
types of people. Yeah. So these parameters, P, Q, V, those are specific to you, right? And so an interesting thing that we also are thinking about now is like, this has actually been a story about one person and a platform, but it's really about a heterogeneous population of the platform, each of whom has their own distribution of PQV. And so, for me, a piece of content that's Moorish but low quality might for you actually not be Moorish at all and be very high quality, right? And so like some people genuinely don't like documentaries about fonts, and some people do. And so there's going to be like every item is going to be different for every user, and right, there are going to be types of users. And so I think one thing that we've been looking at a little bit is as the platform changes the content, you'll see people differentially leaving, right? And so actually another way to try eliciting some information about utility is to watch the sort of differential departure of people, right? People are leaving, the ones who are staying for longer. That may tell us something about that wedge based on exactly the differences.
Fantastic. Let's thank him again and ask.
All right, thanks very much.
And which is probably most important, and that is I'd like to thank our incredibly tireless and excellent superb staff who put this event together, and maybe all the staff that are here, can you stand up and we can give them a round of applause? We'll do it again, but thank you very much. And